Like always, I have the written version with lots and lots of more detail than what I'm saying in this video actually, linked below. Like the blog post is linked below. This is the draft version that I always keep in my Notion with everything that we're going to talk about and that we're going to do. And for the practical, I'm going to use a micro-K8s cluster, and I'm going to talk a little bit more about that in a second. Hello everybody and welcome to another YouTube video here on my channel. For those who are new here, my name is Anais and I make videos and create content around a challenge called 100 Days of Kubernetes, where we aim to explore something new related to Kubernetes across 100 days. Now today we're going to look at RBAC. I hope I pronounced that right. What is RBAC? RBAC stands for Role-Based Access Control. And it's basically used to create specific roles within your Kubernetes cluster, for your Kubernetes cluster, to allow different applications and different users different access rights. Now, when you are the only one who's using a Kubernetes cluster, you likely want to be the Kubernetes, cluster admin of the cluster, right? You want to access everything. You want to be able to change everything that could possibly be changed, and you want to be the one who has complete control over the cluster. However, once you invite more people to contribute to the deployments running and other workloads running on your cluster, you have to think about the different roles that you have within your cluster and who has access to what. Now, the benefits of using RBAC and spending lots of time investing into setting it up and modifying it and so on is that it can make your cluster a lot more secure. Because people can't just delete, for example, resources that they shouldn't be deleting. That's one advantage. Now, another one is that if Alice can access her namespace where her app runs by herself, she's a lot more independent. So she can operate her part of the application independently from other people and can take control over it. So she's not dependent on a cluster admin to make changes for her. There's obviously this entire other philosophy called GitOps, where you basically tell anybody who needs access to your cluster, just push things to Git, and the configuration makes sure that the cluster is updated without them having to have direct access to the cluster. But that's a different topic, and you can check out different videos linked up there for more information on GitOps. In this video, we will focus on RBAC. And now, the main disadvantage of RBAC is that it can get pretty complex pretty quickly. That's a huge disadvantage. If you have, let's say, 100 different users on your cluster and they all have different RBAC permissions. Now, in that case, you will likely have some of a system versus RBAC files to manage those users. What is RBAC and how do we set it up? Well, RBAC is part of this API group within your Kubernetes resources. So we've looked at lots of different Kubernetes resources before in previous videos. And as you can see, for example, in this deployment resource that we have here, we have here the API group apps version 1. That's the API version that this deployment is part of. So you have for different API groups, different resources. And I don't know the details on that, so don't ask me further questions. And this is not what this video is about, but I can dive into the specifics of that because it's something that I never really think about. It's just I'm using different API groups for different resources, right? So it's part of this API group. And we can differentiate for RBAC between roles. That's what we have. Then we have cluster role. So we have role, cluster role. And these two define, ultimately, what can be done. So they say let me move my mic, what can be done. So for example, edit or delete, view. And they are based on, it's a similar model to REST APIs, if you know about them, where you can basically post as one of them commands. And roles and cluster roles basically define what can be done. What are the actions that can be taken and what are the difference between role and cluster role? Well, role is namespace constraint. So you would want to have, for example, if Alice can only access the Alice namespace, then you would use a role for her, right? Versus cluster roles are cluster-wide. So you would want to manage cluster-wide resources with cluster roles. Roles, namespace specific, cluster role, cluster-wide. So with cluster role, you can also manage resources that are across your cluster. For example, access to specific nodes, right? You wouldn't want to have people, like if the master node is accessible, you wouldn't want to have everybody accessing it, for instance, right? And then you have, how can we move to the side? Here, we can move to the side. Then we have, for role, we have role binding. And for cluster role, we have cluster role binding. Binding, I think that's how you write it, not too sure. And what are role and cluster role binding? Well, they say who can do it. Both of them say who can do it. So role is what can be done, and cluster role binding is who can do it. And that allows you to also have kind of this multi-connect, this that one role, I don't know if one role can be connected to many role bindings, but I think many role bindings can be connected to the same role. That would make sense, because then you can basically say what can be done and multiple users can do that, right? That would be kind of the relationship between it. So what can be done, and then you say who can do it is, for example, Alice, Bob, and Charlie who can do it, right? And that's kind of the idea. That's like the broad overview of what do we have within Kubernetes to manage roles. Now, depending on which managed Kubernetes provider you are using, you would not necessarily, I don't think you would use necessary roles and cluster roles and role bindings. You would manage that usually, like the access to a Kubernetes cluster, through the account. So for example, in GCP, you would manage it through the roles that they have there. And I think that's very complex, and it's not something that I had to deal with a lot before. As you can tell, like I'm just learning about that. Now, the last differentiation that is made in Kubernetes is between roles for users and roles for software. Like, for example, when you install Crossplane or Argo CD or any other CNCF project inside of your Kubernetes cluster, it will create, usually it will create service accounts, and the service accounts, they manage the access rights for software. So they are usually used for software. Now, service accounts could also be used, and we will see that now in the practical part. Service accounts can also be used to create access rights for users, but that's not best practice, as I have been told, and it should mainly be used for software. And for users, we use users accounts and different ways to create the users for our Kubernetes cluster, not necessarily through service accounts. And now let's jump to the practical part. Like always, I have the written version with lots and lots of more detail than what I'm saying in this video actually, linked below. Like the blog post is linked below. This is the draft version that I always keep in my Notion with everything that we're going to talk about and that we're going to do. And for the practical, I'm going to use a micro-K8s cluster, and I'm going to talk a little bit more about that in a second. But first, we're going to create a new user called Bob, who has access to the Bob namespace. And we're going to do that through this kubectl add-on, this plugin. And you can manage plugins through another tool called Crew. And Crew is pretty cool because you can manage lots of different kubectl plugins through Crew. And I just actually discovered this, and it's a game changer in a way, because you can have so many different plugins. And we're going to use this plugin to create a service account and then connect the service account to a role and role binding for a user. That's kind of the plan. I haven't done it completely, the practical part yet, so we see how it's going to work out in practice, what I'm saying. Okay, I'm here on my micro-K8s cluster, you can check out how to install micro-K8s from the blog post. It's linked there. So kubectl get notes, and you can see my notes. It's a one node Kubernetes cluster that's running locally. And the way it works with micro-K8s is that it's spinning up a virtual machine, and inside the virtual machine is my cluster. Like that's how it's running on Mac and Windows. It can run natively, like directly on your Ubuntu without requiring a virtual machine. So if you use Ubuntu, that should be your go-to local cluster. So I have here this directory where I have a namespace YAML file, nginx YAML, and a role YAML. Now I will use them in different ways. And first of all, I'm gonna use the plugin that I just showed you with Crew that I have already installed. So first of all, I needed new namespace. So I have two namespaces, one for Bob and one for Alice. Now I'm going to create a role first called Bob. And Bob has access to the cluster. He can create new resources, he can modify resources, but I'm not going to allow him to add, to delete resources. I don't trust Bob enough, sadly yet, to delete my resources. So Bob is not allowed to do that. He has to come to me, to the cluster admin, to actually delete any resources. And first of all, I'm going to do that with a service account. So here's my service account. I'm not going to make that namespace specific. Create service account Bob. So I created the service account Bob. And then I'm going to create a role for Bob. And as you can see here the verbs define: get, list, watch, create, and update, right? And then what type of resources I'm allowed, deployments, to update or to modify or to list or look into, right? So I'm going to create this cluster role, meaning it's cluster wide, right? Bob has access across the cluster to different resources, but he's not allowed to delete them. But he can modify like these resources. Like he can modify namespaces, deployments, and pods. There are lots of resources that he will not be able to access across the cluster, right? So that has been created. Now I need a cluster role binding that's specifically linking to the service account and to Bob. And this is probably the most straightforward way to create a new... Oh, I didn't want to create it within the Bob namespace. Let's create it outside the Bob namespace. Already exists. So, okay, cluster role binding is cluster wide, so it doesn't even matter that I put the namespace. Okay, so if we now look at that, and you can find all the commands in the blog post link below, right? And I look for role, and this is right now I'm the cluster admin, right? Role, cluster role. I can see over here that here we have the Bob cluster role, right? And here's my admin cluster role that has been created when I created cluster role binding. That's the next thing. So cluster role binding is here, Bob binding, right? Let's take a look again at the cluster role and see what Bob has access to. So as you can see here, Bob has access to the namespaces, to the pods, to status, like of deployments, for example, to deployments. And deployments are under a specific API group, so the API group is listed here as well. As you can see, those are the 4 resources that Bob will have access to. He is not allowed to delete anything, and I think that K9S really gives this really nice visualization. Awesome. So lastly, I want to access that kubeconfig for Bob, right? So I'm gonna say Bob kubeconfig, and it's Bob from the service account, and then I want to access that. So I'm gonna do that with just exporting that kubeconfig. We called it Bob kubeconfig, and now as you can see, I'm here first on my micro-K8s, my default admin account, and then I switch to the context micro-K8s default, and this is the default account for Bob. So if I look now at K9S, it doesn't show me anything, right? If I go for notes, it doesn't show me anything, and it actually tells me, oh, you're not allowed to look at those. If I look for role, right, it doesn't allow me to look at those. If I look for namespaces, it allows me to look at those. I can access the Alice namespace with nothing running inside. I can access the application namespace. However, if I try to delete a namespace, it tells me, you're not allowed to do that, right? Bob is not allowed to do that. So let's spin up a deployment inside this namespace. So I have here my nginx deployment, cat nginx. And this is my deployment, right? It spins up a replica set of 2 and namespace Bob. And now here, as you can see, the container image, it's a bit of an older version of nginx. This is just taken directly from the Kubernetes documentation. And before you deploy any container image, you should check for vulnerabilities. And that's what I've done with this container image before. So that's how I know I shouldn't actually use it for my actual deployments. I will show you in one of my next videos how you can check for vulnerabilities, which is very exciting and which you should always do. Now, we are gonna apply this file, kubectl, or deploy, however you want to call this. The file. Now I already specified in the YAML that I want to deploy to the namespace Bob, but I can still write namespace Bob just to be sure. So the nginx deployment has been created. So I'm gonna open up Kubernetes again. And now if I look for deployments in the application namespace, obviously not, there's nothing inside. Namespace, if I go to Bob, here are my 2 pods running, and I can go to deployment, and here's my deployment, and here are my 2 out of 2 deployments running, pods running of the deployment. Now I can again try to delete it, and I'm not allowed to do that, right? And that's the whole point of me creating separate access, like for user separate access, let's say. That's basically it. Now, obviously, you wouldn't have, I can't just give somebody now the kubeconfig and access that cluster because the cluster is running locally for me. So next, I'm going to show you another way that you can create new users and have them either for their own kubeconfig or have them added in your kubeconfig or something like that. Like, for example, I mean, it might also be a use case where you have a large cluster and you don't want to use always the admin account because you might be breaking things accidentally, right? That can happen. For example, when I was working at Sibo, we would have different accounts as like for my day-to-day use versus when I needed to modify resources or add resources that are more high risk, let's say. So I would use different accounts for that. So in my day-to-day cluster fixing, and deploying things, I wouldn't just break accidentally something that shouldn't be broken, right? Okay, so we're here in the same directory that I showed you before, and I have several different files, and I will explain you how you get those 2 files now in a second. First, however, we want to create a namespace. So right now I have these namespaces. You can see I have an Alice namespace that was kind of me trying things out. And then we're going to create a new application namespace. And I have here the namespace definition, Kubernetes resource, namespace YAML. And it's basically just a normal namespace resource. It's a namespace application and it has a label called Alice. Just added to it, and that's why we're going to create it through that. I could also just say kubectl create namespace, but I want to have it defined declaratively. Check out the blog post if you want to refresh the difference between declaratively and imperatively definitions. So we're going to create this and we're going to apply it. Kubectl apply file namespace, and we're going to create this new namespace. Get namespace, and now it's added. Now, right now, I'm on my admin account, and I want to create this new user. So first of all, I'm going to create a role, and that's already here, cat role.yaml. And as you can see here, this is a new role, and this role is different to Bob earlier. It's not a cluster role, it's a role, meaning we make it namespace specific. It's going to be namespace application. And the name of this role is going to be Alice because this role is going to like specifically used for Alice. And here's what Alice can do, which is get, create, watch, and list pods, specifically pods, not deployments, not anything else, no, just pods. That's what we're going to do. So we're going to go ahead and apply this. Apply and role.yaml. Okay, so this is going to be created. Now I want to create a cluster role binding, and I could do it also declaratively, or I can use the imperative method, which I'm going to do now, where it's basically I'm going to create a user kind of through the role binding called Alice, and so you can kind of think about it in that way. And Alice is kind of the entity to which the role is connected to. So Alice is who, and the role is what can be done. Think always about it, who and what, right? Role binding is the who, role is what can be done. It's a bit confusing, but eventually you get there. So kubectl create role binding Alice for role Alice that we've created. So here is the name Alice, right? And we're gonna link it to the Alice with the user Alice. That's gonna be the name, and then the namespace application. So we're gonna create that. Now I can go ahead and look at it through KNMS, for example. I can go to when it opens up. Come on, you can do it. Yes, okay. So in my application namespace, I don't have any pods. I can look at cluster role binding. And in my cluster role binding, I have the Bob binding. And I don't have the Alice one. Where's my Alice one? Cluster role binding. Oh, it's a role binding. That's why. It's role binding in here, not cluster role binding. Here's the Alice one. It's of type user. It's a user role binding. Now you have different ones. You have in total, by default, for role bindings, you have cluster admin. Oh no, that's something else. Never mind. But it's of type user, and it's for the role Alice. And connected to the role Alice that we made, and the name of this role binding is also Alice. This kind of gives you a different view to depict the different information, right? So we're gonna exit this, and next we have to create some keys with openssl. That's how we're gonna create the keys. So here's the first key that we're gonna create for Alice. The Alice key. The Alice key. Sounds very important. And then we're gonna create a second one. With the Alice key, we're gonna create a Alice CSR. The CSR is the Alice that anything that's .key has to be private, and then the group is gonna be user. It's gonna be user group, and what is the other part? You can read about this part in the blog post. So we're going to create that. So now I have those two. I have Alice CSR and Alice.key. Now we need those two files here, ca.crt and ca.key. What does CA stand for? It's for certificate authority. Now, when you have a new cluster, you have a certificate authority that's within that kubeconfig for that cluster. And well, the certificate authority, the public version of it. Now, where can you get this information? You can get this information from the master node, usually. Now, in our case, we're using microkits, and it's going to be different for every cluster. And in many clusters, like many managed clusters, many managed providers, you can't even access that information through the cluster because you don't have access to the master node. So I've been told. So where do you get this from? Well, microkits runs on Windows and on macOS, a Mac, inside a virtual machine, because it runs on Ubuntu. So it needs a virtual machine to run on it, versus if you use microkits on Ubuntu, it's running right on your operating system, something like that. I can make a separate video about that, or you can check other resources linked in the blog post. Now, we want to get the shell for our cluster. So we can say multipass, which is the VM that's running our VM. And you can see here I have two VMs running. and we can say multipass shell and then microcates VM, and that's how we can access it. Now we need sudo rights, and then we can go to the following path, and the thing is we need this var file. But if I say cd var, there's nothing because there's no, it tells me there's no directory, no var directory. It's like, it's not there, right? Not good. But the funny thing is, and somebody did that for me because I was struggling so much finding that location with the certificates, right? So somebody told me you can actually do that. Or you could do that. Why can't I do that right now? Current. Okay, now I'm current. Now certs, not creds. cd certs. Okay, so I'm in the certs directory. That's where we want to be, okay? So this is the path, current. And then I want to be in the certs. Now you can't access the certs if you're not in the root, if you're not logged in as root. Okay, so what's in here? Here are the ca.crt and ca.key. And I just took it and I copied it into my normal directory. So I'm gonna exit this. And as you can see here, I just copied it into here, right? And I need those here. And I need those two keys now. Now they are specific to your cluster, right? So I'm gonna use them now for the next command. And I'm basically using this just like from different tutorials, right? But basically I'm now creating this alice.crt folder that's going to be used to log in as Alice later on. So I'm going to create that. And now that I have that, I can tell my kubeconfig where the information is set. So set credentials for Alice. The client certificate is alice.crt, which we just created. And the client key is alice.key. Now, let me show you where that information is. If you go to your kubeconfig, right, and it's in your kube folder in your home directory, probably. So we're going to access the config in here now. Now, I'm not going to show you the other parts, but basically what we want to do, what we have to do is, for Alice, we have to set the path to those. So they are here set right now. Now you would want to store them in a more secure location than in your code RBAC file. So I'm going to delete it afterwards. So, but if you use this properly, you would want to store it in a more secure location. And then we have here the Alice context. That's the, in this part, the context is set for the next command that I'm going to show you. So the next command is going to set the config that we're going to use. So I'm going to paste this. Config set context, Alice context. We're now going to name this Alice context. It's Alice's context. Cluster microcates cluster. If you don't know about the cluster name, what's your cluster name, you can do is look at your kubeconfig, and your admin is going to be here. And the admin has also a cluster. So it's going to be basically using the same cluster name. That's how I figured it out. It's something so simple, but if you don't know, you don't know, right? And it's in namespace application, right? User Alice. So now everything is set. Now we want to use the Alice user to access the pods that are in that namespace, right? Paste. Now this is found in the namespace, in the application namespace. But if I say get pods in namespace Bob, it tells me it's forbidden to access the namespace Bob. I'm only allowed to access the application namespace. So let's check K9S. Right, never mind. I didn't use Alice here. Can I use context Alice? Does that work? Okay. Application namespace and namespace. Okay, now I have the context, Alice context, and as you can see, I'm not allowed to see anything else beside besides what was in the application namespace. And that's kind of the idea. Now this is it for today. I hope it was useful. If it was, please remember to hit the like button, subscribe to my channel. If you have any questions, comment below or join the community chat, also link below. Link below is the blog post. I hope to see you in one of my upcoming videos. If you cannot wait until then, I also have a weekly DevOps newsletter where I share free online learning resources from across the space, from amazing people such as yourself. So make sure to subscribe. Have a lovely day. Bye bye.